Okay, we're going to do this little video on, I'm going to check my sound levels first, sorry for the delay. Good, okay. We're going to do this on partial fraction decomposition. So one of the things before we start solving a problem is we're going to break this up into the partial fraction decomposition forms. So I'm going to do that first with several problems. What we have to do, and all the ones that we're probably going to do, is linear fraction breakdown. We're probably not going to do quadratic or cubic type breakdown. So this is a quadratic equation, but it breaks down into two linear equations. So what you want to do is factor this the best that you can, and that is the factored form. Now the breakdown is going to be this. We're going to have a over each one of the linear factors plus b over the other linear factor of x minus 14. Now we're going to solve this type of problem after I go through the process of several examples of actually doing the partial fraction decomposition breakdown. So x minus 2, this will be x squared plus 4x plus 3. I'm going to factor that denominator the best that I can, and if I can break it up into linear factors, I'm probably going to be pretty golden. So those are the linear factors. So we can write this as x minus 2 over x plus 1 multiplied by x plus 3, and the breakdown will be, not solving just the partial fraction breakdown, will be a over each of those individual factors. Then it'll be plus b over the other individual linear factors. So the breakdown is not a real difficult process to do. If we look at we look at another one of these problems, it's going to be a little bit different. I'm going to factor that denominator again. It's going to be an x squared that comes out of that, and I'll be left with x minus 10. So we're looking at all the possible denominators that we could have with these individual linear components. So this is going to be a over x plus b over x squared plus c over x minus 10. Now, if this was an x to the third, I'd do an x squared, and an x to the third. If it was an x to the fourth, I'd do x squared, x to the third, and x to the fourth. So just giving us the heads up here. So this would be the breakdown for that unique problem. Another problem that, just looking at this, I'm going to try to do all the different possibilities that you're going to see. So if we look at this denominator, taking out the GCF, it will be x squared again, then it'll be left with 4x plus 11. So this is I'm going to say that denominator has a multiplicity of 3 for this one variable. So I can write this as a over x plus b over x squared plus c over 4x plus 11. The key here is to be able to get the partial fraction breakdown without actually solving it first. But when we get to the point of solving, we'll have to go through the process of doing something different to solve. But this is the first step on every partial fraction breakdown. Break it up into its linear and quadratic factors if we can. The x squared is a linear factor, but it is made up of two linear factors of x and x. So this is unique in that way. So we've done 3 of these, just the partial fraction breakdowns, and then we're going to actually solve them shortly. Okay, this is where we have that situation here, where we have a linear factor, but it's used 3 times. So all the possible factor denominators that we get from that would be x minus 5 squared, and x minus 5 to the third power. So we'll have this as A, B, and C up here on the top. And then just another type of example again. Let's make up another one of these. Let's call this the same similar type problem of x minus 5 to the 4th power. So this is a linear factor with a multiplicity of 4. So we'll write this a over x minus 5 plus b over x minus 5 all squared plus c over x minus 5 to the 3rd plus d over x minus 5 to the 4th. So I use that 4 times. I'm looking at all the possible denominators I can have with that. Now we're not actually solving these just yet. We're just coming up with examples of how we do the breakdown. Once we get process down, we'll be good with actually solving. So another one of these, very similar, 6x plus 5 over x plus 2 to the 4th power. That's just like this other previous problem, so we have to do the same thing. A over x plus 2 plus b over x plus 2 all squared plus c over x plus 2 to the 3rd plus d over x minus x plus 2 to the 4th power. So that would be the breakdown. And that would be a good 6 or 7 examples of partial fraction breakdowns without solving. Solving will be a different story, but this is the breakdown. Now let's actually try to solve one of these, maybe a different problem altogether. So in this case, I'll write this breakdown after I factor it into x minus 3 and x plus 2. So this will be a over x minus 3 plus b over x plus 2. Now, actually solving this is going to be not a real difficult thing to do, but what we're trying to do is kind of look at this exact problem that we have up here and say, what two fractions could I add together to be equal to this fraction here? So you can see I have the individual denominators. When we're looking for a common denominator, I'd be multiplying these together, which would indeed be equal to that. So that's something that's kind of important to see. Now, so this is my breakdown for this. In the common denominator, this would be x minus 3 times x plus 2. So if we look at this as a common denominator, in order to go from this fraction to this fraction, you know I have to multiply both top and bottom by x plus 2. So this would be a over x plus 2. Looking at this second one, in order to have this denominator, where we start with this denominator, I have to multiply both top and bottom by x minus 3. And then when we add these fractions together, it should be, we're trying to look for something that what is going to be a and what's going to be b, to have these two fractions add together to be equal to this result. So looking at the top, putting this all over the same common denominator of x minus 3 and x plus 2, I'm going to distribute the a to each item contained within the parentheses. This will be ax plus 2a plus bx minus 3b. Now if I look at like terms, ax plus bx plus 2a minus 3b, all over the common denominator of x minus 3 and x plus 2. Now, looking at this, we also see that adding these components together, we could say a plus b multiplied by x plus 2a minus 3b. Now, a plus b is representing the coefficient of x. So if we look back at our original problem, the coefficient of x in this case is 1. So I can say that a plus b has to be equal to 1. And then no variables here except the a and the b. And then I could say 2a minus 3b has to be equal to 7, because that's the constant term. So these is going to be the constant term. This is going to be the coefficient of x. So now this gives us two equations with two unknowns. I'm going to write these on this piece of paper so we can make sure we can see them and I don't lose paper at the end. So a plus b is equal to 1, and 2a minus 3b has to be equal to 7. And that's what we had here. Now I'm going to solve this system of equations. But let's say I'd like to get rid of the b's. That could be a choice, or I could get rid of the a's. It really doesn't matter, but just to be different, I'm going to multiply this equation by 3 so I can get rid of the b's. So this would leave me with 3a plus 3b equal to 3, and 2a minus 3b is equal to 7. Now when I add them together, I will have 5a is equal to plus 0 is equal to 10. So therefore a has to be equal to 10 over 5, which is equal to 2. And then to solve for the other variable, I can plug that value of 2 back into either one of these equations, and it doesn't matter which one. So I'm going to take back to the easiest one, be a plus b is equal to 1. So plugging in 2 back into that, I have 2 plus b is equal to 1. So b would be equal to 1 minus 2, which is a negative 1. So we know what a is, we know what b is. I know a is equal to 2, and b is equal to a negative 1. So go back up my very original equation, x plus 7. X plus 7 over the x minus 3 multiplied by x plus 2 is equal to a over x minus 3 plus b over x plus 2. So we've established the fact that a is equal to 2 and b is equal to a negative 1. So now this will be 2 over x minus 3 plus a negative 1 over x plus 2. Now this is, again, if I were to add these two fractions together, it should be equal to this. Again, when you do that, you have to find the common denominator, but I'm pretty confident this is the correct answer, so I'm going to live with that one. Let's do another one of these equations. Let's do something that's a little more challenging. Like we did before, the first step is factoring the denominator. And the GCF is x, and I'm left with x squared plus 2x plus 1. Further factoring. And that's a three-term, that's a trinomial, so I can break that down into two binomials. So now I'm going to take us back to a previous type of problem, which is going to be very similar to this one. I'm going to write this as 5x squared plus 20x plus 6 be x and x plus 1 all squared. So when I do my partial fraction decomposition, we'll have to take care of both the linear and the quadratic component factors of when we take this to the power of 2, take this to the power of 1. And like in this case, we had to have each one of these linear factors as to the power of 1, to the power of 2, to the power of 3, and to the power of 4. So we're going to have to do the same thing with this problem when we do the breakdown. We got the 5x squared plus 20x plus 6 all over x times the quantity x plus 1 all squared. So this would be 1 over x, a over x, plus plus the b over the x plus 1 plus the c over the x plus 1 all squared. So again, knowing how to do the breakdown first is going to be the biggest deal of all. And this represents the lowest common denominator. That is the lowest common denominator. So I'm going to take each one of these denominators that I have and say I need to convert to the common denominator of trying to find the A, B, and C associated with what three fractions will add together to be back to my original. So this is like doing fractions in a backwards method. To go from this fraction to this fraction, hopefully you see that I have multiplied both top and bottom by x plus 1 all squared. And to go from this fraction to this fraction, I have to multiply the b by a single x and an x plus 1. And then if I do the c one, I'll have to multiply both top and bottom by x to be equivalent to this fraction. So that's kind of important. So be able to find common denominators. That's something that we've been plagued by since day one of math, I think. If I put this all over the same denominator, and a couple of things you can check to say if I did this correct, if these canceled, would I be left with what I started with? The answer would of course be yes. In this case, if the x factored and one of the x plus 1's factored, I'd still be left with x plus 1 on the bottom with the b on top. Looking at this one, if I multiplied top and bottom by x, I know that if I canceled the x's, I'd be back to where I started with c times c over x plus 1 all squared. Now I'm putting them over the same denominator. And x plus 1 all squared is going to be a times the quantity of x squared plus 2x plus 1. That's when you square x plus 1. You get x squared plus 2x plus 1. So just keep that in mind. In this case, when I distribute this, this would be x squared plus x multiplied by b. And this final term would just be cx. Now I'm going to distribute the a to each and every item contained within the parentheses. So this would be ax squared plus 2x times a, if you like to do that, and then plus a, distributing the a to each item contained within the parentheses. Then I have plus bx squared plus bx plus cx. That would be all my pieces of the numerator. I know this looks kind of challenging, but it's really not all that hard, I don't think. So I'm looking at like terms. So I look at the like terms of ax squared plus bx squared, put those together. Then I'm looking at those terms that have x's in them. So the terms with x's would be 2ax and bx and cx. So these are all the x terms. I'm going to rewrite this as 2ax so it looks like the others, plus bx plus cx. And then we got one final constant term, which is a. So that's my remaining terms. So we look at those common factor, or the like terms, all the ones with just x, then the like terms are the ones with the x squareds as well. just give myself a little room, I'm going to write that again on another piece of paper. So I'm going to actually look at these and say, of these two terms just right here, I can write, if I factor out the x squared, I would have a plus b left. And then looking at these three terms, I'll have all the variable x. I'm going to factor out the x and I'll have 2a plus b plus c plus the a all by itself. So all I did was go from this step to this step, is to factor out the x and factor out the x squared. Now, if I look at my original equation, I'm going to write that up here as well. I just want to take us back to where we started. I just recopied that. We have that here. So I can look at a plus b has to be equal to the coefficient of x squared, and that would be 5. The coefficient of x squared is 5. Then we can write 2a plus b plus c would be equal to the coefficient of x, and the coefficient of x is 20. And then from here we can say that a is the constant term that's all by itself, and the constant term that we have is by itself is going to be the 6 would be equal to the a. So now we got these three equations with three unknowns in a way, but these are quite easy to solve, because if I were to plug in 6 back into a, I'd have 6 plus b is equal to 5. Therefore b would be equal to a -1. We know what a is, we now know what b is, so we can, like, if you like, I'm going to just put those. So those I know. If I go back to my original equation, I'm going to plug a back in. 2 times 6 plus a -1 plus c has to be equal to 20. This would be 12 minus 1 plus c is equal to 20. 12 minus 1 would be 11 plus c is equal to 20. And c would be equal to 20 minus 11. And c would be equal to 9. So I know what a is, I know what b is, and I know what c is. So when I go back to my original equation again, I'm going to write it one more time just so we can kind of visualize again. 5x squared plus 20x plus 6 is equal to the a over x plus the b over x plus 1 plus the c over x plus 1 all squared. So from this we know a, which we calculated from the previous page, is equal to 6. So this would be 6 over x plus a -1 over x plus 1. That was b. And we said c was equal to 9. Ideally, if I were to add these three equations together with the common denominator, we'd be back to where we started with. 5x squared plus 20x plus 6. was a little bit of work. I'm sure when you get to class, we're gonna be doing a few more, so. That's kind of two good examples of solving these partial fraction decomposition type problems. So I'm gonna stop with this, finish this up.